Exploring Succession Among Tree Populations in Point Pleasant Park Post-Hurricane Juan by Kendra, Emily, Emma, and Kieran. Hurricane Juan devastated Nova Scotia in 2003, with CBC News reporting winds greater than 145 kilometers per hour, causing major disturbances to much of the native wildlife across the province. For Halifax's Point Pleasant Park, the hurricane caused major wipeouts of its native flora, with only 30% of the trees remaining after the storm. Point Pleasant Park is a Halifax staple enjoyed by many residents and tourists for its Acadian forests, but became close to an empty land after the hurricane. As well, Point Pleasant Park resides on Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq people. Point Pleasant Park is known as Amtukati to the Mi'kmaq, carrying the meaning of the Spirit Place. The Spirit Place has a great meaning for the Mi'kmaq, as it was a place where Mi'kmaq could maintain and live through their gratitude for the land and amongst the unique Acadian forest, who too owned the land. After Hurricane Juan, many questions remained as to how and if the Acadian forest within Point Pleasant would recover from such a large disturbance. Succession, as under Turchin's definition, is how the disturbance of Hurricane Juan affected and changed the forest within Point Pleasant Park. Research about similar disturbances have been conducted before, such as for the upland hardwood forests in America. These researchers wanted to see how the hardwood forests with different sized and newly formed forest gaps caused by Hurricane Opal in 1995 have undergone succession during preceding years. Though there is research about the succession of other forest types after major disturbances, the research for Acadian forest succession is limited. Our study wants to figure out in which ways did the Acadian forest species in Point Pleasant Park change within its succession. Specifically, we looked at the total forest density, the species richness, and the changes amongst the most dominant species of red spruce and red maple trees to determine how the forest changed after Hurricane Juan from 2004 to 2022. We predicted that the overall succession of Point Pleasant Park would follow a steady incline. Specifically, we hypothesized three variables: that the total forest density would increase until its climax community, that the dominant species of red spruce and maple trees would repopulate, and that the species richness would increase each year after Hurricane Juan.
After Hurricane Juan, 6 study sites were established in Point Pleasant Park, located in the areas of highest impact on the forest structure. From 2004 to 2022, once a year, data was collected from these sites at similar times of the year. 3 data sets were collected, breaking each site into quadrants to make collection more efficient. The first was the tree density per species per site, collected using identification and observation. The second was tree size in centimeters. To collect this, the diameter at breast height, approximately 1.3 meters, was measured for each tree per site. Lastly, the plant cover was measured. Using 50 centimeter by 50 centimeter quadrants, each site was averaged based on findings in condensed sections, determining overall average plant cover by species.
Here is the data that represents the total forest density calculated from the densities of each species in areas of 400 meters squared at Point Pleasant Park each year after the hurricane until 2022. A linear regression analysis resulted in the slope of the regression line to be 0.5281, indicating that almost 53% of the variance in the data is accounted for. There was a significant positive relationship between year progression after 2003 and total forest density within Point Pleasant Park, which is shown by the F statistic being 83.9 and the p-value being 7.4 times 10 to the power negative 14. This indicates that the total forest density increased each year after the hurricane. This regrowth can be due to the new environment the forest has to adapt to after the hurricane, along with new resources that are available for different species, just as in the study of Burley and others. Burley and others found that the greater sunlight exposure from the absence of forest density and the organic debris left behind from the hurricane are factors that contributed to species being able to regrow. It can be predicted that as the total forest density reaches its climax community, the density levels will remain stable due to the max potential of the environment being reached after regrowth of all species.
A linear regression model was used to examine the population density of red maple. Population density per 400 meters squared throughout the park was collected from 2004 to 2022. There is found to be a weak positive relationship between tree density and year, showing that the overall density of red maple has increased since 2004 but continues to fluctuate. Although overall density has increased during the study period, the linear regression equation only accounts for 19% of variance in the data and is therefore not an accurate way to predict the density of red maple trees in Point Pleasant Park.
This graph shows a relatively steady increase over time of the species distribution and density of the red spruce. The higher outlier points indicate that some areas of Point Pleasant Park are seeing more intense growth, but the average is consistent within the population density growth. Density has increased in the red spruce population from 2004 to 2022. It was originally the dominant species as opposed to red maple. However, the red spruce population is no longer the dominant species as red maple has taken over quite significantly. The red spruce population has had a relatively steady slow growth in its density. It has seen some spikes over the years. However, the overall trend is steady linear growth, whereas red maple has a massive increase in the density from 2004 to 2022.
The overall density of red maple and red spruce has steadily increased since 2004. Secondary succession led to the recovery of the population of dominant species and others. Red maple and red spruce can be expected to remain dominant in their environment. Their overall density will continue to steadily increase, and climax community will eventually be reached. When climax community is reached, biodiversity will be more limited as certain populations outcompete others. The whole ecosystem will become increasingly stable until ecological events occur and cause disturbance, at which time the secondary succession cycle may start over again.
Between 2004 and 2022, there was an average increase in species richness per 400 meters squared of 7.17. This was statistically significant with a degree of freedom of 1 and a p-value of 2.2 times 10 to the negative 16. After the hurricane, the species richness dropped and remained extremely low for about 7 years. The recovery of local species then began through secondary succession, demonstrated by the consistent increase. The pioneer species returned early, slowly giving way to the intermediate species. This trend will prevail, progressing towards a climax community through the continual increase in species richness as biodiversity recovers.
The Acadian forest within Point Pleasant Park is currently undergoing a stage of mid-secondary succession, a natural process in which an ecosystem begins to regenerate after a disturbance or catastrophic event. The term mid-secondary succession refers to the intermediate phase of regrowth. The park experienced significant damage due to the hurricane, resulting in the loss of many species within the Acadian forest. This disturbance might have led to the destruction of habitats, uprooting of trees, and a decline in the overall biodiversity within the ecosystem. Being an urban park can have an effect on succession. Two of these effects are species availability and site availability. Species availability refers to a species' ability and survival of disturbances. Dispersal, the species pool, including native and non-native species, and human preference. Pioneer species, the first species to reestablish in an area, modify the environment, messing with the development of other species populations through inhibition. Humans decide what plants should be present using herbicides and other chemicals. Site availability refers to the disturbance and death of sites, landscape changes as they become urbanized. Urban succession is also different from that in rural areas, meaning there is more human interaction through making wide paths for human traffic and disturbances, unintentional or otherwise. Two-wide seeing is a concept that originated from the Mi'kmaq people. It emphasizes the importance of blending indigenous knowledge and Western science, creating a holistic approach that considers multiple perspectives. This approach isn't just about recognizing different viewpoints, but understanding that the integration of these perspectives can lead to more comprehensive and effective solutions. For the Point Pleasant Park forest's growth and conservation, two-eyed seeing approach might involve integrating practices such as controlled burning, species selection based on traditional knowledge, and the understanding of ecological relationships, alongside Western scientific methods like detailed biodiversity assessments, soil analysis, and advanced monitoring technologies. This integration allows for more comprehensive strategy to ensure the forests reach maturity and sustain ecological balance.
We would like to thank our instructor, Dr. Allison Schmidt, and our teaching assistant, Alexander Gonzalez, for their help. They have fostered important ecological concepts and skills needed to prosper in this course. We would also like to thank Dr. Allison Schmidt and the past students of the Introduction to Ecology class for collecting and putting together the data from Point Pleasant Park needed to create this scientific presentation.